Hello everyone, in this video I want to show you how to draw a project network. Okay, the first thing I want to do is I want to draw a activity node so that I can use it as a reference. Let me draw it here. Let's draw a circle first, and we divide it into 6 parts. We call this activity I, and the duration is Ti. And we have earliest start time, earliest finish time, latest start time, and latest finish time. Okay, and then we can get started on our first activity A. Activity A takes 3 days to finish. Okay, let's get started. Let me draw it here. Activity A takes 3 days to finish. And for the first activity, the earliest start time is time 0. And the earliest finish time is earliest start time plus the duration, which is day 3. And I want to write down the bullet points when we are drawing the project network. And right now we are working on the forward path, because we are working from the first activity to the last activity. So forward path, bullet point 1, the earliest start time of activity 1, the first activity is time 0. Bullet point 2 is earliest finish time for any of the activity equal to earliest start time plus the duration. Okay, and then let's move on to activity B. Activity B takes 4 days to finish. Okay, and activity A is the predecessor of activity B. And the earliest start time of activity B is the earliest finish time of activity A, which is day 3, day 7. And bullet point number 3 is earliest start time of its successor is equal to the earliest finish time of its predecessor. Okay, and then move on to C and D. Activity B is the predecessor of C and D. Activity C takes 3 days to finish, and activity D takes 10 days to finish. Day 7 copy down, 10 and 17. Okay, and then move on to activity E, F, and G. Okay, and activity D is the predecessor. So we are going to have 3 arrows coming out of activity D. Activity E takes 8 days to finish. Activity F. F takes 4 days to finish. And activity G takes 6 days to finish. And then we can copy down day 17 into its successor's earliest start time. And day 25, 21, 23. Okay, and let's move on to activity G. Activity G has 4 predecessors. Activity H has 4 predecessors, C, E, F, and G. So that should be 4 arrows converging into activity H. Activity H takes 8 days. So here we have to choose a date to copy from. We usually simply copy the earliest finish time from a predecessor down to the early start time of its successor. But for activity H, we have 4 days to finish: day 10, day 25, 21, and day 23. And in the forward pass, we will choose the maximum number or the latest date, because we have to make sure all the activities ahead of H are finished. So that should be day 25, and then 33, and then activity I and J. And then activity I and G. Okay. And then activity K and L. Activity K takes 4 days and L takes 2 days. Okay, and last one is activity M. And again, we need to choose either day 42 or day 40. Here we are choosing the later date, which is day 42, so that we make sure K and L are both finished before M gets started. And the completion date is day 46. And then I want to write a little bit more on the key point number 3. And when we have multiple earliest finish times to choose from, we always choose the maximum or the latest. Okay, and that completes the forward pass. Now we finish the forward pass, and now let's continue with the backward pass, which is we are going from the last activity to the first activity. And we start from activity M, and the start point is the latest finish time of activity M, and we will copy day 46, which is the earliest finish time, down to the latest finish time. 46, and 46 minus 4 is 42. Latest finish time of the last activity equals to the earliest finish time of the last activity. And then we do the subtraction and get the latest start time of any activity equal to latest finish time minus the duration. Okay? And then let's move on to activity K and L. Activity K and L are the predecessor of M, and we have to make sure that K and L are finished before M can get started. So if M can start on day 42 as its latest start time, so K and L must be finished by day 42. And the latest finish time of K and L are both day 42. So we copy 42 here and we do the subtraction. Okay, key point number 3 will be the latest finish time of an activity equals to the latest start time of its successor. Okay, and then we continue with our calculation. 38. And now we are on activity H, and we want to find the latest finish time of activity H. It is either day 33 or day 35. In the backward pass, we are going to choose the smallest number or the earliest date, because we want to make sure that the predecessor is finished before the successor can get started. If the successor I can start on day 33, then H must be finished by day 33. So here we choose day 33. Okay, and we copy day 25 down. And now we are on activity D. D is a predecessor of E, F, and G. Here again, we are going to choose the earliest date, which is day 17. And between 7 and 22, we are going to choose 7. Okay, that completes our backward path. And I want to finish all my bullet points here. So last one, the latest finish time of an activity is equal to the latest start time of its successor. Sometimes if there are multiple latest start time of successor available, then we are going to choose the minimum number or the earliest date. Okay, and that completes the backward path. Next, I'm going to show you how to calculate the slack. A slack is equal to the latest finish time minus the earliest finish time, or it equal to latest start time minus the earliest start time, and they are always equal to each other. So let's calculate the slack. 0, 0, 15, 0, 2, 4, 0, 0, 0, 2, 0, 2, and 0. Now we finish calculating the slack. With this information, we can identify the critical activity and then the critical path. So for all the activities with 0 slack, they are the critical activities. If we connect them, we will get the critical path. So we are going to connect all the activities with 0 slack, and those are the critical activities. I'm going to connect them. Oops. And the critical path is A, B, D, E, H, I, K, M. And last, the critical path is always the longest path. That completes the project network lesson. Thanks for watching.